Hello students, welcome back to my YouTube channel Mathematical Lens by Namitha. In this video, we are going to continue with chapter number 8, playing with constructions of grade 6 mathematics of the new NCERT textbook Ganitha Prakash. And here we are going to explore rectangles, right? So here first what is given is construct a rectangle ABCD with AB 7 centimeter and BC 4 centimeter. So first let us construct a rectangle and then see what is further asked. So let us now construct the rectangle. So we take AB as 7 centimeter, which is already given. So we make it as a base. Mark 2 points at 0 and 7. And make a line A, B. Mark the points A and B. Now we take a protractor, keeping A as a center and just match this line. We mark 90° at some point, right? Because you know all the angles of rectangle are 90°. Similarly, keeping B as a center, always check the baseline, it should match. So 90°, mark a point, right? You can draw a line a little beyond, a little larger line on both the sides, right? Now AB is given as 7 centimeter and BC is given as 4 centimeter, right? So we take our compass and with the help of a scale, first we check 4 centimeter. We open the compass for 4 centimeter radius. Once this is done, keeping B as a center, cut an arc. Similarly, keeping A as a center, cut another arc, right? Because opposite sides will be 4 centimeter each. So also 4 centimeter. Now this point you can mark as C. First let us join C and here it will be D. So this is point C, this is point D, right? So we have got our rectangle ABCD with opposite side as 7 centimeter AB and CD and the other opposite side BC and AD as 4 centimeter each. Now if you wish you can remove the extra line which was drawn. Okay, so you get a perfect rectangle. Fine. Now imagine X to be a point that can be moved anywhere along the side AD. So this is side AD. So anywhere along you will need to mark a point X. Similarly, imagine a point Y. It can be marked on BC. Okay, anywhere along BC. Note that X can also be placed on the end point at A or D, right? That's your choice. Similarly, Y can also be placed on the end point B or C, right? So here you can see there are 4 situations given. You can see here X is marked 5 mm below A and here Y is marked 1 centimeter above C. Similarly, then they are joined XY. Then here 1 centimeter below A, here 2 centimeter below B. In the third situation, you can see this is at point D and this is at point Y. And then those lines are joined. And in the fourth situation, A is X, X is at A and Y is at B. Okay, so it is overlapping the line AB. Right, now based on this scenario, there are questions asked. So let us try to answer those questions. So at which positions will the point X and Y be at their closest? When do you think they will be the farthest? what does your intuition say? Discuss with your classmates, right? So looking at the four previous pictures, also you can like guess that if you see the fourth picture where X is on A and Y is on B, right? So at that they seem to be closest. And farthest, when one point is at D, X is at D, and Y is at B, that they seem to be farthest, right? Now verify your guesses by placing the points X and Y on the sides and measure how near or far they are. So we will check all these things. We will keep different positions of X and Y. I'll show you that. And how can it be the minimum length, which is equal to length AB, and how it is maximum, which is equal to its diagonal, right? And there are some questions also given over here. We will try to solve them also, keeping X and Y at different places, and we find out the length of X and Y. So first, let me show you the different position. Like suppose this was kept at first one, like 0.5. Now you should know it was 0.5 centimeter, that is 5 mm, means between 0 and 1 the middle line. Okay, so here was a point X and point Y was 1 centimeter above B, right? So somewhere here. Okay, so now if we check this distance of X and Y, right now I'm not marking, I'm just giving you an idea how it keeps on changing, right? So this one position we have taken, this is X and Y, this is around 7.4 centimeters. Okay, now if we keep it at D and at B, like their diagonal positions, see it is more than 8, it is around 8.5, it is around 8.3, you can say. Okay, now when we keep it on the points like D and C, it is around 7 centimeters, so it is less. Here also on A and B, it is 7 centimeter. It has to be 7 centimeter because it is along the line AB and CD, and diagonally it is maximum. Or at other all other positions, if you keep on moving, just see it is less than 8. If you can just see the position from diagonal, like I keep it at diagonal, and then slowly I just tilt this scale, change the position, it will go on reducing, right? You just see to it that this 0 position remains somewhere, but at all positions you can see it is decreasing, and when it comes exactly straight it will be 7 centimeter. Okay, if they are exactly along uh, the vertex AB or CD, right? Means 5, suppose 2 centimeter from A and 2 centimeter from B. If I take that distance, it will be exactly 7 centimeter because it will be along the line AB or CD, right? So what we conclude that which position at diagonal position like BD and CD, the length will be maximum. Okay, and along the vertex, if both the points are on the vertex, then it will be the minimum position. Now we try to answer the questions, the 3 questions which are asked at different positions. So when X is 5 mm away from A, right? Depends where you have written A, either above or below, but it is 5 mm. So I mark it here. And Y is 3 centimeter from B. Okay. So somewhere here. Now let us measure the length. So this is 0 and here it is 7.4 centimeter, right? So 7 centimeter and 4 mm. That's your first answer. When X is 5 mm away and Y is 3 centimeter away, then XY is 7 centimeter 4 the length of xy. This is the first answer, okay, which is given on page number 198. Now x is 1 centimeter away from A. So I mark the point over here. And y is also 1 centimeter away from B. Right? And then we measure the length. Now this has to be 7 centimeter, right? Because it is, both are at the same distance from the vertex A and B. So in the second question, x is 1 centimeter away, y is also 1 centimeter away from B, and xy is equal to 7 centimeter 0 you can write. Okay, it has to be exactly 7 centimeter. Now the third question, when x is 2 centimeter away from A. So I take 2 here and I mark a point. And y is 4 centimeter away. That is at point C. It will overlap, right? Because this BC is 4 centimeter. Right? So now if I join this 2, you can see it is little more than 7. It is around 7.3 centimeter, right? So when x is at 2 centimeter away, y is at 4 centimeter away, then xy is 7 centimeter 2 right? So these are the answers to the questions which are asked. There is a table given. You can try with different positions of x and y and measure the length, right? You will understand the concept better. So have you checked what happens to the length xy and when x and y are placed at the same distance from AB respectively? Like here some cases are given. So we observe that the length of xy remains the same, right? 5 from A and B. So length of xy will be 7 centimeter. Okay. Similarly, 1 centimeter, 1 centimeter. In all the cases, the length of xy will remain 7 centimeter if they are at the same distance from the vertices. So in each of these cases, observe how the length of xy compares to that of AB. It is same, right? And the shape of the four-sided figure ABYX in all these cases will be a rectangle only, right? Only the distance between B and C will decrease, otherwise it will remain a rectangle. And how does the farthest distance between X and Y compare with the length of AC and BD? So farthest distance is the diagonal. Is equal to the diagonal, length of the diagonal. Diagonals, both the diagonals, length of, to the length of diagonals AC and BD. Right? So we drew this conclusion and this is applicable for any rectangle which you draw. I hope you have understood this concept. We'll continue with this chapter in the next video. Thank you.